Okay, this is K2. I'm here to explain how to use my VAV and air handling unit sizing spreadsheet that includes macros. So we have 5 different types of systems. We have a warehouse that's single zone constant volume, an office, which is a VAV type system, fellowship hall that has an ERV and has a high latent load due to many amount of people, and a sanctuary that also has a ERV because of the high latent load due to the many people, and a classroom that has a DOAS that does the ventilation, and a VRF with we'll say cassettes in each room. These are the printouts and the reports that come from HAP that I'm simply importing into my spreadsheet. So let's open up the spreadsheet and I'll show you how to knock this out. Hopefully this video will be a half hour long. It's how long I think it can be. So project name, project number, project name, the elevation. This is where you go to the general info, and the elevation, you put in the electric service available, choose between 283 phase and 483 phase, and natural gas available, yes or no. And this is where you have the ventilate. You're essentially removing unused tabs. So there, as you can see here, there are a lot of tabs that may be overwhelming, and it's just to handle multiple different situations. So you would type the letter yes, Y for all of the schedules that apply. So we do have a ventilation schedule. We'll say our VAV boxes are have some cooling only, some VAVs with electric reheat. We don't have any of these. We don't have any hot water reheat. We don't have any fan power boxes. Let's say we do have energy recovery, packaged rooftop units, and a packaged rooftop unit, yes, and no split systems, but you could. So all you do is hit this button. It'll remove all of the schedules and tabs that don't apply. So now, as you can see down here, there's less tabs. It's more manageable. So let's split this screen here. And let's open up the first one. So, step 1, you go here, copy, then go to HAPmaster, which is where we are, and you're gonna paste the values there. That's right click and then paste values. So here, don't Control C and Control V, because if you do, it'll look like this, which you don't want. So we're gonna paste those values. Once you do that, head back over to the left, and this is where you put in RTU-1, and for any single zone constant volume system, it's going to be both the system and zone are going to be the same name. So 135A, 135B, 135C, 135B. All right. Then you go to systems. So RTU-1 serves the warehouse. Then you pull in, go up to the top of this, move to the left. You pull in this airflow. So this is single zone system. So the block and coils and some of the peaks are going to be the same. So 1933, 1933, and let's do this. So this is telling the spreadsheet what the leaving air temperature is. And we're going to say 54 degrees off the coil. And that's 1 degree of sensible heat gain. And then we need to bring in the humidity ratio, the grains per pound. So put in 54 degrees dry bulb at 100% humidity because it's subcooling and wringing out moisture, so it's going to be fully saturated. And at the 1,200 feet of elevation is equal to 65 grains. So we're going to do 65 grains, and we're going to move this out of the way. And the heating, this is not a VAV system, so we're going to say 95 degrees out of the unit. And we'll see where that leaves us. So Now we're done with this. We're going to close that tab and then go to the next report that HAP generated. I'm going to pull that over to the right. Go back to the, well, while we're here, why don't we do this? RTU-2, this is our office, and you pull in this number here, 6481, and this number here. So coil is 6481. This is 7423. So this gives, no matter what leaving air temperature we choose, it's going to maintain the percent difference between these. And this will be the same, the leaving air temperature off the coil, but it's not going to be 95 degrees out of the unit. It's going to be 55 degrees out of the unit, and the electric reheat will take it the rest of the way. All right, so let's bring in the information from down here. Simply highlight and scroll down, Control C, and then right click and paste. Go to the right. We're going to highlight all of that information, and we are going to right click and paste. So now we need to do what we did with the other ones. This is the index number that's going to be used for the entire project. 107, this is room 107, 103, 102, 101, 105, 111, 113, 114, 115, 112, 116, 117. This is the most inefficient part of this spreadsheet, I would say, where it sometimes can take more time than is ideal, but this is setting up the spreadsheet for automation. So the time spent here is saved later by a lot. You'll see that 126A, 126, I like it capitalized, 126B, and that's it. So the spreadsheet is going to create ventilation schedules, VAV schedules. It's going to create rooftop unit schedules with ERV, or you don't have to do this part where I'm deleting. It's just going to be unused information if I don't, but I like it being clean like this. So VAV 1-1, VAV 1-2. This is where you're assigning which spaces are going to go on which VAV box. VAV 1-4. Okay, so that's done. Close this, open up the next one, the next report. I'm going to move this over here, and let's go down to where our information is for copying and pasting. Go down here, paste those values, scroll down here. Move to the right and paste those values. Now let's put in our reference numbers. 217B, 214, 215, 216, 213, 215. And since this is a single zone system, this will be the same for both. Okay, now we go up to the top. This is the fellowship hall. So we'll go to Systems, RTU-3 Fellowship Hall, and that airflow is 4383, 4383. And this information here will be the same as RTU1. That one's done. Let's import information from the sanctuary, which is also ERV. You're going to have an ERV most likely. So let's copy this information, go to the hat master, bring in the space information, the space load information, and the ventilation information. So this is 331A, 331B, 331C, 332, 332A, 332B, 333, 325, RTU-4, RTU-4. All right, now let's go to Systems, RTU-4, RTU-4. This is the sanctuary. And what airflow are we looking at for that? And this information is going to, of course, be the same as that because it's not a VAV system. So that is it. We can close this. Now there's also a VRF with DOAS, but we'll get to that later. So let's make a copy of this. Create a copy. -2, and let's just make it generic, AHU. And we have RTU2, we have RTU3 and 4. RTU, okay, 3. Okay, RTU4. So now we have we have to bring in, oh, I skipped one step. My apologies. Very important step. You have to copy all of these numbers and then go over here and right click, paste those values. Then go to Data, Sort, because I like having them in all in the nice order. Continue with current selection, select that, and then hit Sort, uncheck that box, and hit OK. So it comes in clean like that. Now, let's go to Zones. So we need to copy and paste this. So this just automatically brings in our system, our VAVs and rooftop units that are single zone constant volume. And I'm going to hide that. Now, let's say VAV for RTU, this needs to be, all of these need to be RTU2. Okay, and I am going to cheat and make this easy. And just do this. All right. Now, when I go to the Zones tab, you can filter like this, makes it pretty easy. So this is all of the VAV boxes on RTU2. So let's say RTU1, 2, 3, 4 all have electric reheat. So you would go here, and 5 and 6 does not, down here, we'll say. But we'll say 9 does, 7 does, 8 does, and 10 does. So all of them have reheat except for VAV 1-5 and 1-6. So unfilter that. All right. So this is telling us that in in order to heat the space and meet the envelope load, the required leaving air temperature is right here. And that's based off of this number, which was imported from HAP. This is the heating MBH. And this KW is based off of what your entering air condition is, and that delta, your entering air, which is 55 coming out of the unit, and heating that up to what's required. So that is 5.6 for this one. But we're going to use nice round numbers at 6 kW, and you can see in column AI, the resulting leaving air temperature is 92.9 degrees. So let's say this one is 7, this one is 2, so it's 83.7 is good. You don't want anything lower than 85 just for the sake of creature comfort. So let's say 5. Oh, this one's lower, so let's make that one 6. So this one is a 4. Where does that leave us? Ooh, that's really low, 72 degrees. Let's heat that air up to, we'll say 6 kW, 7 kW. There's 85, that's good. 4, 2, make it 3, and this one is a 4, 81.1, so maybe say 4.5 kW. All right, so now that that's done, you just go over to here and you put in VAV 1-5, VAV 1-6. This is our cooling only. So those schedules are done. You just do price, ESV, or whatever. And these are the ones that have electric reheat. So it brings in, it's going to size put the voltage and phase based off of the electric service available and the KW. It's going to change this, the voltage and phase. So VAV 1-1, VAV 1-2. I am going to make this easy, bring that down to 10 because that's how many there are, and saying, oh, there's an error here, but that's because we had cooling only on those. So go down. We're going to copy those values and paste them there. All right, so as you can see, voltage and phase are different depending on KW. Smaller KWs will be on a smaller phase. So you just copy and paste that there. And ventilation schedules for the entire project are done for all of the spaces, and it has different system ventilation efficiencies. So RTU2 has 65% ventilation efficiency, RTU has 76, RTU3 has 76, and RTU4 has 75, and it has the uncorrected outdoor airflow and the corrected, which just takes the uncorrected and divides it by the 65, by the system ventilation efficiency for that system. So ventilation schedules are done at that point, and you can copy and paste that into CAD. So we have ventilation schedules done, VAV schedules done. Now it's time to do our rooftop units. So we have RTU-1, it would be like this, RTU-1 you type in. Now you can specify ASHRAE cities or just standard cities, or Jason Hellman has a Pittsburgh number that's 9076, which corresponds with this. So all you would do is so if you change this, you could say just Philadelphia. So that's that. So you would want to copy and paste the dehumidification numbers in there. You could take New Orleans. All right, different cities are in here, but Pittsburgh is also in here. But let's do Pittsburgh's Jason numbers, which is 9076, which corresponds with this. Now we need to first specify the space temperature and humidity set point, which is 75 degrees at 55% relative humidity. So what you do is you do 75 degrees at 55% relative humidity, and that corresponds with 74.7 grains right there. So that's the amount of grains that needs to be in the space. But there's internal latent load. Okay, so this is a warehouse, so the type of work here is not office work, it's probably standing. So that corresponds with 4.8 MBH, and the dehumidification airflow is 720 CFM, which is less than the cooling CFM, so I'm going to size based off of the cooling CFM. 1580, and this is the ventilation airflow right here. So 490 is what I'm going to do. And over here you have the minimum airflow, the design airflow. Okay, so the minimum airflow is just based off of if you make it exactly this and exactly that without any safety factor, without any rounding or anything. So just to see what the minimum requirements are. And this is 1580. Capacity is 5.4, 43.9, 21.4, and 68.6 is so. And this is all. This information is getting pulled from right here. And it also will tell you the square foot per ton. It'll tell you the CFM per square foot total. So this is seeming pretty light, but it's a warehouse. And the condensate that is pulled out. So it'll also tell you if energy recovery is required by code, if economizer is required by code, if return air and smoke air detectors are required. So this is our unit, and now let's round it to 500. The ventilation is rounded to 500, and this is rounded to 1600. So we're going to document that here, 500 and 1600, just to give it a little bit of rounding, nice even numbers. Okay, so that one's done. Now let's go to RTU2. RTU-2. This is our office. That's a VAV system. So the ventilation airflow is 1600. And this is office work, 114 people, so 23.5 latent MBH. The dehumidification airflow, in order to maintain 55% relative humidity, is 74.7 grains, which corresponds with the dehumidification requirement of 3,560 CFM, which you can see here. So compare these two. The cooling airflow is more, and the block CFM is less than the sum of the peaks. So the VAV boxes will be sized off of the airflow. If you sum up all the airflow to VAV boxes, it would equal 6820. But the system doesn't need to be sized for the sum of the peaks, because some parts of the building will be peaking at different times than other parts. So that difference between, this is what you need to size the leaving air, size this is what you need to size the unit at. So 5,690, all right. At office work, good. So we just do 19.8, 160.9, 76.5, 240.7. Oh man. Oh, this is the ventilation airflow. My apologies. 1600. Supply airflow 5960. Number of tons 19.8. 160.9 sensible. 76.5 and 240.7. Now let's do a little bit of rounding and let's make this just 6,000. So energy recovery is not required. At this percentage of 26%, you're allowed 16,000 CFM before you need energy recovery by code. So we don't need energy recovery. That's good. 1,600 and 6,000 CFM is going to result in 19.9 tons, 162 sensible, 76.5 latent, and 241.7. All right, then you go to RTU3. Ventilation required is 22,050, and this is a fellowship hall. So these are people who are going to be sitting. All right, so again, to maintain 55% relative humidity, the airflow that's required to do that is 4,550. That's based off of the difference between the grains in the space relative to the grains in the leaving air out of the unit. And that's based off of the grains off the coil. So at 65 grains, as we inputted right here, associated with 54%, 54 degrees fully saturated, means that you need 4,550 CFM. So as you can see, typically cooling drives, but if there's a lot of people, a lot of latent load, there are times that, if there's a lot of people or that they're in a gym, there's lots of, like if the occupancy classification was heavy work, you would need a lot more air, right? So let's put this back to what it was, seated at rest. So we need 4,550 people. Okay, so this tells me over here you need energy recovery, economizer, and smoke detectors. All right, so this one is now done. So let's do our minimums. 2050, 4550, capacity 19.1, 136.6, 92.5, 242.3. All right, and let's round this to 2100 for even numbers, and let's make this 4600. 2100, 4600, and that brings us to 19.4 tons, 138.1, 94.1, and 246.9. Done. RTU4. This is sanctuary. So this is 3,610. All right, so this has more people. This has more people. So we're running into a problem. We've got a ridiculous amount of dehumidification airflow. So 15,000 CFM compared to cooling is 5,730. So what you can do is increase the, if you would like, you can either increase the allowable relative humidity to maybe maximum of 56, which is 76.11. Oh, but this is office work. These people are sitting. So it's going to drop us down to 8,840 CFM, which is a lot closer. So that's good. Let's also make this 56% relative humidity, which corresponds with 76.1 grains. Now we're at 7,000. Let's go with that. This may not be the final decision. You're going to talk with Jason, Chris, Tony about this, but this is just to show the mechanics of the spreadsheet. So 7720 is what you would size it off of in order to meet that dehumidification requirement. Another thing you could do, of course, is to go back here and go to your systems. We're having trouble with RTU4, so let's change this to, maybe we get 53 degrees off the coil. So instead of 54, so 53 and 100% relative humidity, that is 62.7 grains. So let's go back. So now instead of 7,720, if we got just 1 degree colder, we could get a 6,400 CFM units. So that's what I'm going to do. I'm going to get colder air, and we're going to assume 2 degrees of sensible heat gain, which is realistic still. So we still need energy recovery, economizer, and smoke detectors. So let's put that away. And our ventilation airflow minimum is 3610. Supply airflow 6,400 and 31.3 tons, 164.8. Latent load is sensible load. 210.8. 164.8 is the latent, and 391.9 is the heat. All right, so, and we're just going to run that for our design as well. So our design is our minimum, and then you're done. So then all you do is go to here. So this is our energy RTU with energy recovery tab. So you just go here, RTU-3, RTU-4. those were the ones that did have energy recovery requirements here and here. So all you do is insert the required number of rows and push the magic import button. So it gives you the estimated number of tons that are required, and that's including the capacity that's achieved by the ERV. Gives you where it's space it serves, outdoor airflow, supply airflow, the required leaving air temperature off the coil. So we talked about 53 degrees for this one, and the total versus sensible. You don't have to send this stuff to the rep. You can delete this if you would like. So it gives you the entering air conditions for both. Actually, this would be removed because this is an ERV. So this is going to be pulled off the entering air is going to be pulled off of the it's going to be pulled off of the performance of the wheel, and it gives you outdoor air. It gives you like all of these requirements here, and it also tells you that's it. So then you go to packaged RTU. So this was the first two. RTU-1, RTU-2, RTU-1. So you're going to insert the number of rows and then import all of the information, copy, paste it, send it to a rep. Okay, same thing. And this will also tell you, it tells you these notes apply. 2 applies to RTU1 and 2 and 3 apply to RTU2. So energy recovery not required, economizer is required for both, and the return air and smoke detector are required for just RTU2. Automatically does that. So then we are done with these schedules. So we have 5 schedules automatically created. One more thing to do, which is the VRF. So we're going to grab the last report. All right, this is pretty easy as well. So all you do is go down to so you copy and paste the zone peak sensible loads. So you go here. Copy. Right click, paste the values. Then go down to the ventilation right here, copy down here, and paste those values. Now is the labor intensive part where you go to each of the zones and pull in the latent load. So this first one is 7350. The next one is also 7350. 7350. This one is 2520, 2100, 43.8, 2206, 2206, 410, 4787, 2069, and last one, RT13, is 2069. Okay, so now you are done with this. And you can choose what percentage of the latent load the fan coils, these VRF units are going to handle. We'll say 100%, so the DOAS is only responsible for not humidifying with the ventilation air. It's not going to do any of the dehumidification load. So with that, this is what you would send to the rep. for the ventilation load. So the sensible was 12.6, but when you add the latent load, the total capacity needs to be 20. Okay. So over here, so this is serving the classrooms. So the minimum is saying I need 2030 CFM. All right, but let's see what is required. So what I'm going to do is I'm going to make this 75 degrees at 55% relative humidity in order to not dehumidify. So what leaving air temperature do I need off the coil to not humidify with this? So not humidify the space. So I put in 75 degrees during cooling, and I want to maintain 55% relative humidity, which means my leaving air temperature off the coil needs to have 74.7 grains. Okay, and what is the associated leaving air temperature? So I'm going to switch this to grains, and 74.7 grains, and I'm going to make this 100% relative humidity, and I'm going to look for what the dry bulb is associated with that. So I need to cool down to 57.7. So we'll add in a little bit of safety to that and say 56 degrees in order to not humidify the space. If we did, yeah, so we'll say 55, just so everyone who loves that number feels happy. So, oh, and that's what I have here. Coil dry bulb and the associated grains with that is 67. So let's put the ventilation airflow in here, 2030, 2030, and we are done. We can send this to the rep, and it'll give them the requirements right here for cooling and for heating, our airflow and what it needs to cool it down to, which is 55 in this case. So that is it. Let me know if you have any questions. Just ventilation schedule's done, cooling VAV box schedule's done, VAV with electric reheat is done, packaged rooftop unit with energy recovery is ready to send off to the rep, and same thing with the packaged rooftop unit that doesn't have energy recovery. So I hope this was helpful. Let me know if you have any questions. Thanks. Bye.